Hi, so this is our ME350 Project 1, completed by Nicholas, Jacob, and Christopher. So we chose problem 3, which is the two-dimensional solid steady state model for a vaccine packed in styrofoam with some refrigeration around it. This is our schematic, and the dimensions that we chose, it's based off of a Pfizer packaging diagram that we found online. This is how we chose to mesh it up with our delta X and delta Y, both equal to 2.5 centimeters. We chose 1/8 of the area through symmetry to make it simpler. Our assumptions were a steady state, constant material properties, and negligible inner cardboard around the vaccine. And then those are some of the values that were given. And these are the results. In the table above, so it shows the temperature for each of the nodes getting warmer around the outside and staying at -20 beside the vaccine. And now if Nicholas would like to talk about some of our nodal derivations.
Yes, so for our nodal derivations, we chose to use square nodes. And we started, doing the important nodes, and we used that to generalize and solve for the rest of the nodes. So one of the nodal equations we did was for node 33, which is the inner edge node or inner corner node. And we started off with the first law of thermodynamics and then wrote out all the heat transfer equations. And all of them were conduction. And it actually simplified that Q2 equals Q3 and Q1 equals Q4 through symmetry, right? And then we ended up solving for the energy generation. We did some simplification, and that at the end we ended up getting that equal to 2K times T33 minus T24. So one of our other nodal equations that we derived was for T10, which was a inner node that was connected to the side we cut off. And that was also a square node. And once we simplified the first law of thermodynamics, we got it so that it would be 0 equals Q1 plus Q2 plus Q3 plus Q4. And Q2 equals Q4 through symmetry. And then that eventually simplified so we could solve for our equations.
Okay, now I'm gonna pass it off to Jacob to show the ease code.
Right, so let me share my screen here. All right, so right here we have the givens that from our problem statement, and then we assume that the interior nodes were, nodes 28 through 33 were at the same temperature as the vial. And then we just entered in all of our equations that we derived in the hand calculations here. And then we also assumed that each of the interior nodes, 28 through 33, generated their own individual amount of heat, or rather absorbed it. And then we, through symmetry, we found the total energy generation. And then if we go down here, we can find all of the results here. We have negative values for our energy generation, as you would expect from something getting colder. And then we have all of our temperatures here in Kelvin.